Think about this. You're standing in front of a massive wall of concrete, holding back millions of tons of water, and somehow it doesn't collapse. Not from the pressure, not from the weight, not even during heavy rainfall or flooding. So here's the real question. How do dams actually control that much water without failing? Because if they didn't, entire cities downstream could disappear in minutes. Let's break it down. First, you need to understand what a dam is really fighting against. Water doesn't just sit still, it pushes, and the deeper you go, the stronger that push becomes. At the bottom of a dam, the pressure is insanely high, way stronger than at the surface. So instead of building a flat wall, engineers design dams to handle that force smartly. Take gravity dams, for example. These are the thick, heavy ones made of concrete. They don't try to fight the water, they simply use their own weight to hold it back. The base is extremely wide and it slowly narrows toward the top. So the deeper the water pushes, the more solid structure it meets. It's like trying to push over a mountain. Now here's where it gets even more interesting. Some dams don't rely on weight alone. Arch dams are curved, and that curve isn't for looks. When water pushes against it, the force gets redirected into the surrounding rock walls. So instead of the dam taking all the pressure, the canyon itself helps carry the load. That's smart engineering. But holding water is only half the job. The real challenge is controlling it. Because water levels are always changing. Rain, rivers, melting snow. If a dam just kept holding everything back, it would eventually overflow. And that's where spillways come in. Spillways are like safety valves. When the water rises too high, they give it a controlled path to flow out, safely. Instead of water rushing over the top and damaging the structure, it gets redirected through channels designed to handle extreme force. Some spillways are so powerful they can release water faster than a natural waterfall. And then there are gates. Massive steel barriers that can open and close depending on how much water needs to be released. Operators monitor water levels constantly and adjust these gates in real time. Too much water? Open the gates. Too little? Close them. It's a constant balancing act. Now here's something most people don't think about. Water doesn't just push horizontally, it can also seep underneath, and that's dangerous because pressure building under the dam can weaken the foundation. So engineers install drainage systems inside the dam itself. These systems relieve pressure by allowing small amounts of water to pass through in a controlled way. Think of it like releasing air from a balloon before it bursts. And then there's sediment. Over time, rivers carry sand, dirt, and debris. If that builds up behind the dam, it reduces storage capacity and affects how water flows. So dams are designed to manage that too, either by flushing it out or controlling how it settles. Now put all of this together. A dam isn't just a wall, it's a fully controlled system, holding water, redirecting pressure, releasing excess, monitoring risk, all working together every second. Because the goal isn't just to stop water, it's to control it precisely. And the moment that control is lost, the consequences are massive. That's why dams are constantly monitored, maintained, and engineered with layers of safety. Because behind that calm surface of water, there's an incredible amount of force being managed in real time. And now you see it differently. It's not just a structure, it's one of the most powerful examples of humans learning how to control nature without fighting it head-on. Thanks for watching.